Hello and welcome to R-Instat, another example in R-Instat. We examine data from a small survey on rice yields. Start R-Instat, use File, Import from Library, Load from Instat Collection, Browse. Use the Excel file called Introductory Guide Datasets. Choose the sheet called Survey and press OK. Examine the data. This example is small, with just 36 rows and 7 columns or variables. This is what we expect. We also note there don't seem to be any missing values. The village variable is a character column and is all in capital letters. Tidy it. Then make it into a factor. Use Prepare, Column Text, Transform. Use the case option at the top. Choose Village from the selector. Use the option to convert to a title. Because you want to replace the existing column, call the new column Village. Then press OK. Right-click in the Village column and use the option to convert to factor. Right-click there again and use the Levels/Labels option. This check is part of the data preparation. There should be 4 villages, but any spelling mistake on data entry would wrongly add another. There are just 4 villages as expected. Close the dialog. Now the variety variable. Return to the transform dialog using the icon on the toolbar. Choose variety and convert to lowercase. Store back into the variety variable and press OK. Right-click in the variety variable, choose Convert to Factor. Right-click again and choose Levels/Labels. This confirms there are just 3 varieties as expected, but the order of the levels, old, then trad, then new, is in their order of appearance in the data. This should be changed so that the legend in the graphs are in the right order. Use Prepare, Column Factor, Reorder Levels. Select the variety and move trad to the bottom and new to the top, then press OK. Nothing seems to have changed, but right-click in the column again and select Levels/Labels. This shows the order of the factor levels has changed. Now, right-click in the last variable and make it also into a factor. Right-click again and choose Levels/Labels. Perhaps reversing them will be better so that they go from lowest to highest application. Return to the Reorder Levels dialog. Use the second of the top radio buttons called Property, where Reverse Levels is the default option. Use the down arrow to store the result back into the same column, then press OK. Use the right-click and Levels/Labels again to check the levels are now in ascending order. Then close the dialog. One objective of the survey was to examine the yield variable. It is in the old units of bushels per acre. This is not commonly used, so divide it by 14.87 to put them into the more well-known tons per hectare. This is an easy job for the calculator that we introduced earlier. Were you comfortable with it? If so, use it. Otherwise, we have a simpler dialog for your most common needs. Use prepare, column numeric, transform. Use the scale tab at the top. Click on divide and type 14.87, then press OK. The variable yield 1 now has the yields in tons per hectare. Next, explore the yields with a pivot table. Use describe, 2-3 variables, pivot table, or prepare, check data, pivot table. Select the village and variety factors as the initial rows. Click to the initial column factor and choose the fertilizer variable. Click to check the numerical variable option and select yield 1, then press OK. Press the maximize button in the output window to view the pivot table. It is often useful to filter the data to home in parts of particular interest. We illustrate, though it isn't so important here, with only 36 observations. Click on the village down arrow and just include the first village. Then press apply. Among the items to notice, the new variety is absent. No one in the village used it. The values for the trad variety are lower than for the old variety. The data are unbalanced. Almost no fertilizer was used for the trad variety, while everyone with the old variety used fertilizer. So, at least in this village, it is impossible to know whether the yield differences between trad and old are due to the variety or the fertilizer. There are only 5 values, but the filter shows there were 7 observations from this village. Return to the village filter and return to using all the villages. Click on the average down arrow and choose count again. This shows that 6 of the cells are from multiple observations. 9 farmers did not apply fertilizer, and all except one of these used the trad variety. However, some trad farmers did apply fertilizer, and one even applied the highest level. Return to using the average, that is the means, and yield 1 and choose the heat map option. The fertilizer effect is now reasonably clear, but any effect of variety is harder to see because of the villages. Move the village factor from the left hand side to the top row. That seems better. There seem to be variety differences as well. However, conclusions about the new variety can only be tentative. Click on the top left down arrow and choose line chart. The 3 lines are separate, and they are all rising with fertilizer increase. So, it looks as though there are both variety and fertilizer effects in the data. We propose that pivot tables and charts are perfect for exploratory graphs, while R be used for final presentations. Close the output window and use describe, graphs, scatter plot. Make yield 1 the Y, and then fertilizer the X, and variety the by variable. Then press OK. Maximize to view the graph. That's a start, but the points are small and a line for each variety would help. Return to the dialog, click on the point size and make it 3. Also, click on the line of best fit. Press OK again and maximize to view the graph. That's quite nice. The three lines are different, so that shows a variety effect. And they all have a positive slope. That indicates the fertilizer effect for each variety. The slopes look similar, so now try to fit a model where the slopes are the same. Parallel lines would imply the fertilizer effect is the same for each variety. Return again to the scatter plots dialog and tick the line of best fit. The parallel lines option is not on the main dialog, so press the plot options button. In the sub dialog, use the layers tab and click to add a layer. Then return and press OK. Neat, eh? Are you now ready for the case study datasets or to process your own data? Almost, but I have two burning questions first. First, I often want to repeat and maybe improve on a graph I have seen elsewhere. We had a graph earlier from the pivot table. How would you get the graph with R or R-Instat? Good challenge. Here is what I was able to produce. As an improvement, it also shows how many observations are at each point. For example, at the bottom left corner, there are 8 farmers who use the traditional variety without fertilizer. Note that the pivot chart used the summary data, as we see, so we need to produce that to work from. Go to Prepare, Data Reshape, Column Summaries. Use Yield 1 as the column to summarize. Then click in the Summarize By and put in fertilizer and variety. Click the Summaries button, then untick the sum and tick the mean. Then press Return. Lastly, tick the original level checkbox, then press OK. Usually, with this dialog, you get a new data frame with just the summaries. But here, we use the original level checkbox to copy the summaries back into the original data. That means they are repeated, and we can therefore show the frequencies. Now use Describe, Graphs, General. Add mean yield 1 as the Y, fertilizer as the X, and variety as the color. Now use the down arrow on the Geoms Add button and choose Line and then Count. Then press OK. So now you have the graph. Why did you use those particular dialogues? The summary dialog simply added another column into the same data frame. I thought that's what the calculator was for. Could I use that instead? You are right. There are often different ways of doing the same thing, so just choose the one you prefer. I'm a calculator lover, but the way above is maybe a bit simpler. And with the graph, I am more comfortable using the line plot or the scatter plot dialogues. Could I have used them? Yes, but those main dialogues don't currently allow this combination of line and count. So you would have to add the second layer to the graph via a sub dialog. This is an unusual example where the general dialog is simpler to use. Now, I really like the parallel lines. I hope I am right that this means the fertilizer effect is the same for each variety, so we can discuss variety choice separately from fertilizer application. But how do you know that the three slopes could be the same? That's another excellent question. It is so complicated to answer here in detail, but let me give you the key idea. Boxplots help to show the general idea. Use describe, graphs, boxplots. Make yield the variable. Ignore the factors but put variety as a facet. We now need an option that isn't on the main dialog, so click on Plot Options. In the Facets tab, tick the Margins checkbox. Then press Return. Click on the Add Points checkbox and reduce the jitter to about 0.05. Then press OK. Press on Maximize to view the graph. This box plot is for all the data. These yields vary from about 1 to 4 tons per hectare. A good analysis explains variability, and the box plots show that quite a lot of the variability is explained by the variety. Can we quantify this? This is undertaken by the Analysis of Variance ANOVA table. Go to Describe, 2/3 variables, Summarize. Choose the 2 variables option at the top. Make yield 1 the first variable and variety the second variable and press OK. In the ANOVA table, you see that the variety factor has a sum of squares of 16, leaving just 6 unexplained. Now I'm leaving you to complete this exercise. Now return to the dialog and try fertilizer instead of variety. That explains quite a lot of variability too. I hope you see the next steps because I'm going to let you do them yourself. If you use the 3 variable option at the top of this dialog, then you can include both variety and fertilizer together. They explain more variability. You can see that the residual sum of squares has dropped from 6.45 or 8.87, with just one variable down to 3.31, with both variables included. You can also see that it doesn't matter whether you add the fertilizer to variety or variety to fertilizer, you get down to 3.31 either way. Notice in the tables that fertilizer has 1 degree of freedom. That's just one slope, so corresponds to parallel lines. Now we add the different slopes. Here are the results. The extra line in the ANOVA table has added 2 more slopes, but the residual sum of squares has hardly dropped. So, the data don't provide any evidence that we need 3 separate lines. The estimated slope, 0.35 tons per hectare for each unit of fertilizer, is therefore reported. In other words, the ANOVA is telling you that there is a difference between varieties and different fertilizer levels give different yields. But there is no evidence that there is an interaction between the two. You are right, there's a lot here. But you know, I am now actually looking forward to this course. Wonders will never cease.